already. Review by nucleophilic substitution, hydration. What else did we talk about? Reduction. Reduction of aldehyde would give you primary alcohol. Reduction of ketone would give you secondary alcohol. The three of the methods that is introduced here, these three are all hydration. The first one is direct hydration, and for each one you need to know if it's going to be Markovnikov or anti-Markovnikov. So the first one was Markovnikov. The second one is also Markovnikov. The advantage of the first one is that it's easier, is fast. The second one, no rearrangement. For the second one, the addition still is Markovnikov. The first one, there is a possibility for a rearrangement. And the third one, there is no rearrangement, but the product is going to be anti-Markovnikov. Since of diols, the bisphenol diol can be synthesized by adding potassium permanganate. If you remember, dilute potassium permanganate would add 2 OHs, 1 to each carbon, and then the hot acidic permanganate or hot and basic permanganate, it can add CO double bond to each side. So from alkene, it will give you either ketone or aldehyde. But if it's dilute, that is the key. Dilute and cold basic permanganate is going to give you diol. So you start with the CC double bond, it would change to OH to each of the carbons. Osmium tetroxide with hydrogen peroxide also is going to add 2 OH groups. And then hydrogenation of the alkene is like peroxide followed by hydrolysis. So these are the new reactions. I think we have it here before we. It would be, we will talk about these two, the hydroxylation, and then about the osmium tetroxide. If the addition is going to be syn addition or is going to be trans addition for diols. Organometallic reagents is used in the, it's also used in preparation of the alcohols. What are organometallic? Organometallic means that the carbon or organic molecule, it carries a metal. So when the carbon is attached to metal, examples could be carbon attached to lithium, carbon attached to magnesium, and when you have the or carbon attached to sodium. What is unique about these organometallic compounds? And it's common and unique for all of what's common and unique for all of them is that carbon carries a negative charge here, negative charge, because the metal is going to carry the positive charge. So that is specific and the significance of the organometallic compounds, because you have carbon carrying the negative charge. If carbon carries a negative charge, now carbon or carbon chain is acting as nucleophile. And we had carbon, other compounds of the organic compounds, that we had carbon carrying positive charge. If the carbon is attached to is a part of the alkyl halide, or carbon carrying the halide is going to have positive charge, because the halide has negative charge, partially negative charge. Oxygen, if you have a carbonyl compound, oxygen is going to be partially negative, and as a result, carbon is going to be partially positive. So any of these organometallic compounds, and what's special and unique about them is the negative charge on carbon, because any metal with metal, metal gives electron, non-metal is going to gain that electron. So when you have a metal, non-metal, for metal, non-metal, so if you have your carbon is non-metal here, is an ionic compound. For ionic compound or ionic bond that you have here, metal is going to be positively charged and metal is going to be negatively charged. So anytime you bring a metal to form bond with carbon, and I know I'm repeating a few times, but that's the unique and specific property of the organometallic compound. It gives carbon a negative charge and is going to make the carbon a strong nucleophile. Now, if you have a strong nucleophile, your strong nucleophile can react with alkyl halide, carbon from the alkyl halide, or it can react with the carbon from carbonyl group. Now, we are going to, you had already one of these reactions, how to make the organometallic compound. To make organometallic compound, you have to just learn a specific case. How do you make the carbon sodium bond? Carbon sodium bond is coming from the acetanolide ion, where you start with terminal alkyne and you mix it with a strong base. Your base must be very strong base. Sodium amide is a very strong base. Like if you bring sodium hydroxide, it's not going to react with the alkyne, because this is not strong enough to react with terminal alkyne or to remove the hydrogen. So we talked about the weaker the base, weaker the acid is, the base that you are using to react with that acid, it must be stronger. So alkyne is not acidic enough to react with sodium hydroxide. So you have to remember, you have to bring in a stronger base, sodium amide, and with the sodium amide you can remove the hydrogen. Alcohol, for alcohol you have to bring in, if it's OH, you have to bring sodium or potassium itself, is just the melting the sodium or potassium as a very strong base in order to remove the hydrogen from alcohol, because alcohol also is not strong acid. The case that you could use the sodium hydroxide was phenol only. So phenol would remove the hydrogen from the sodium hydroxide would remove the hydrogen from phenol, and it changes phenoxide. So terminal alkyne plus sodium amide, it is a review, but now we are classifying as organometallic compound. So I'm reviewing again to make sure that you memorize or to know all in one place how you're getting organometallic compound. And what is unique about all of them is that negative charge on carbon. In order to give negative to carbon, you have to remove the hydrogen or insert a metal. So you have to bring a metal or to make the react with the carbon, or remove the hydrogen without the electron. So you have to remove H+. So this hydrogen must act as acid. So you're bringing very strong base to remove the hydrogen. Now you have acetanolide ion, where you have a negative charge on carbon and positive charge on sodium. The acetylide ion, now acting as a strong nucleophile, it can react with alkyl halide or carbonyl compound. If it reacts with alkyl halide, this is the SN1 type reaction, is going to form bond. So you see you have a negative charge coming in, forming bond with the carbon that has a positive charge or a slightly positive charge, and you have these two categories. Those are the most popular groups that is going to react with organometallic compound. So leaving group is going to leave, and then you get the new carbon-carbon bond. So what is happening in this case, you are increasing the carbon chain. So it's easier, and it doesn't need like a big, very reaction to break the bonds between the carbon-carbon, because you could just heat it up and you can give energy to break it. But making new carbon-carbon bond is a big deal in organic chemistry. So what is happening here, you are adding carbon chain to your original alkyne that you had. So you're adding another alkyl group to the right side, or you are replacing the alkyl group with the hydrogen from the right side, so from the alkyl halide. If you have your acetylide ion prepared and make it react with the carbonyl group, now in the carbonyl group there is no leaving group, and this is your leaving group. So if you don't have any leaving group, now what's going to happen, the weakest bond is going to break. The weakest bond that is breaking here is the pi bond. It breaks over the oxygen. It gives negative charge. Now we have alkoxide. We talked about what is alkoxide. Alkoxide is like it looks like the alcohol functional group that has lost one hydrogen. So if you have oxygen negatively charged, that's in general, that's the functional group now. It takes the priority over the alkyne, and this is the alkoxide, is known as alkoxide. When you have alkoxide, then you can protonate that. To protonate, you would use water or water in acidic solution. So any questions in general about organometallic reagents, organometallic compound? Any questions? Okay. Next organometallic compound that we have is, the next organometallic compound that we have is known as the Grignard reagent. What is Grignard reagent? In Grignard reagent, you do have carbon magnesium bonds. So you have CMgX. So you have your R group on this end, but here you have the magnesium attached to carbon. So if magnesium is attached to carbon, what's the charge of magnesium here? It's because magnesium is metal, carbon is non-metal, magnesium would be positive, carbon is going to be negative. Very good. So we have the negative charge again assigned to carbon, and that is going to make this part of the molecule a strong nucleophile. And why is a strong nucleophile? Because your compound, you take this as a compound, it's ionic, and when it's ionic, it's going to dissociate. So the plus charge, minus charge. So now this part of the molecule is going to be free to attack. And it's going to attack what? It can attack the CX, which is the alkyl halide, or it can attack the CO, which is the carbonyl. If it attacks the CX, it's going to make the X to leave, because that's the leaving group. If it attaches to CO double bond, it depends. If your CO double bond carries also a leaving group, so if it attaches to this carbon group, is going to break the pi bond over. But if it forms bond with this carbonyl group, there's a leaving group here, and this leaving group is going to leave. So if it forms bond, if you're a nucleophile from organometallic, forms bond, or this is like very general, and it's better to learn it this way. If your nucleophile forms bond with the carbon that carries leaving group, the leaving group would leave. If it forms bond with the carbonyl group, depends on the carbonyl group. If there is a leaving group, the leaving group would leave, like this acid bromide or acid chloride or ester, regardless if it's a strong or weak. the leaving group is going to leave. But if there is no leaving group, then the pi bond is going to break over oxygen. And you get alkoxide, then you protonate alkoxide. Now, these are repeated because it's common and it's the same with the acetylide ion. What is new about the Grignard? How to prepare Grignard reagent. A Grignard reagent can be prepared from any example of the alkyl halide. You just add magnesium and you heat it up. You heat up the magnesium with the alkyl halide. The solvent that you are using is specific and it must be ether. And why does it have to be ether? Because ether is a polar solvent and it can stabilize the Grignard. This is a methyl Grignard. So methyl Grignard, methyl magnesium iodide, or if you say methyl Grignard, that means that it has the MgX attached to methyl group. The methyl Grignard is unstable, is very reactive, it needs to be stabilized. And in order to be stabilized, when you get the ether, ether has oxygen with two pairs of unshared electrons, and it can stabilize the Grignard reagent. So the solvent must be ether. Your solvent cannot have hydrogen. It cannot be water. Water cannot be. Alcohol cannot be as the solvent, and you cannot have any ionizable hydrogen like SH and OH. You cannot have as part of the solvent. Your solvent must be ether to stabilize. But you look at this pattern. Like anything, you can start with any type of carbon and halogen bond, and you end up with Grignard. So this is the alkyl. That's a cycloalkyl. You have the allyl. You have the allyl bromide. So alkyl bromide, cycloalkyl bromide, allyl bromide. You could have aryl bromide, benzene ring attached to bromine. So the benefit of this is that it could be any type of carbon halogen bond that you mix with the magnesium and ether, and you end up with the Grignard reagent. The only limitation is having like ionizable hydrogen. You cannot have ionizable hydrogen. Your alkyl halide, it can even be a secondary alkyl halide, and you could get the magnesium in, and you end up with the Grignard reagent. The way it works is that you just add magnesium. The magnesium is going to be inserted between the carbon and halide. So you just open a bracket there, open like a caret there, and you would add the magnesium there. So that's how you write the product for the magnesium reacting with your halide. Could be alkyl, cycloalkyl, or aryl, or secondary. But all you have to do, just open this bond and insert. You're not replacing. Remember, you're inserting the magnesium between the carbon and halide. So no restriction of the alkyl halide. The one that is most reactive is going to be alkyl iodide. It's going to be most reactive. This is not a good, very good. Is not used. We don't start with the fluoride, but any of these can be used definitely. The solvent must be ether, and the formula is RMGX. So you write it as RMGX. When you write RMGS, the carbon directly attached to magnesium is going to have positive charge. Ether is going to stabilize it. Iodide is most reactive. The other organometallic compound that you could have is the alkyl lithium. So we had that, I had this in the summary already. When you have alkyl lithium, lithium is going to be positive charge, and the carbon directly attached to the lithium from the alkyl group is going to have the negative charge, a strong electrophile. How do you prepare this compound? You are going to start with alkyl halide again, with either chloride, bromide, or iodide, and add lithium just like you were adding magnesium. But in this case, lithium is going to replace the hydrogen, replace the leaving group. Okay? So lithium is going to replace it. So you get the lithium halide, and then you just get RLI. So this is not a RLIX because group 1A, it just has one bond, so it's forming one bond. So RLI, you have your alkyl lithium. So any of the halides plus the lithium, just like Grignard. And your solvent doesn't have to be ether, so you could use any solvent that does not ionize or separate this lithium. So it has to be like a you can't use again water or alcohol for it, but you could use non-polar ones. So any questions about how to make acetylide ion, Grignard reagent, or alkyl lithium? It's not always alkyl lithium. It could be aryl lithium, it could be vinyl lithium, or it could be alkyl lithium. So any carbon, any form of the alkyl, vinyl, or aryl halide. Questions? Because the key is how to make it. That's the first step. You have to make your organometallic reagent. If you make the organometallic reagent, on the next step, you are going to make the organometallic reagent to form bond with either alkyl halide or carbonyl compound. So if you have your carbonyl being attacked by the organometallic compound, again, if you have R group here that is, or hydrogen is not good leaving group, and alkyl group is not good leaving group. So if you don't have leaving group, this is going to break over the oxygen, the pi bonds, and then you get the alkoxide. If you have R group, the net result is that the R group with the leaving group would leave. So first the pi bond breaks over the oxygen, second is going to be protonated, and then you end up with alcohol. So this is a method for preparation of alcohol. So let's say you want to make this compound. Using Grignard reagent. What should you start with? You want to use Grignard reagent to make this alcohol. You make butanol. What should you start with? What's the first step? The general steps are make Grignard. Step 1, prepare Grignard. Step 2, make it attack to carbonyl group. Okay, so those are the two major steps. Then you're going to, because it's a primary alcohol, because this is a primary alcohol, this carbon oxygen single bond it used to be carbon-oxygen double bond. It's coming from this. Because there is no one carbon is coming from, one carbon is going to come from your Grignard reagent, and anything else that is attached to this carbon is going to come from the carbonyl group. What else is attached to this carbon? It's hydrogen and hydrogen. So this must have been formaldehyde. So from the alcohol, the carbon that it carries the OH now, it used to carry the, it used to be the CO double bond. Okay, one carbon is coming from Grignard reagent, or one group is coming from Grignard reagent, and everything else, it used to be attached to the carbonyl group. So in this case, there's only hydrogen attached. So you start with the alkyl halide first. You add magnesium. It changes to Grignard reagent. And you want to make sure to include the ether because E is significant here. You will get MgBr, plus and minus. Now, you are going to make the Grignard reagent, in this case. The Grignard reagent is going to attack the CO double bond. For primary, this is a primary alcohol, you must use formaldehyde. And you have to make a table to memorize it. If you want to make primary alcohol, you would use formaldehyde. So Grignard reagent here plus formaldehyde, H and H. A nucleophilic attack, and the pi bond is going to break over the oxygen, and you end up with alkoxide. What's going to happen with the MgBr? The MgBr that you have a positive charge, it can stay close to this to the alkoxide to stabilize it. But since it's ionic compound, it's not going to stay, is not going to form bond and is not a permanent bond here. When you hydrolyze it, and the next step, so Grignard should always follow by hydrolysis. When you hydrolyze it, you're going to protonate the alkoxide. So from the water, H would go with the oxygen, and OH will go with the MgBrOH. So MgBr has a positive charge, OH has a negative charge, is going to give this very stable product. So this is going to be byproduct. We're not worried about the byproduct, but if we know that is a stable compound, is to leave the equilibrium and is going to help the reaction to go forward and make more alcohol. So OH is going to go with the MgBr, and with the MgBr OH, a stable compound, is going to help the formation of alcohol. So what do you need to know? Steps in Grignard reagent. First, you make the Grignard. Second, you make it react with Grignard reagent to make alcohol. First, you make the Grignard. Second, you make it react with the carbonyl compound. And the key is to recognize what type of carbonyl compound that you should have. If your Grignard, your alcohol is a primary alcohol, the carbonyl is going to be formaldehyde. Okay. We're going to prepare, okay, this is the secondary, this should answer your question. This is a secondary alcohol, okay? So we have a secondary alcohol. With the explanation that I had earlier, what should be your carbonyl group? Because what we know for sure that this carbon, it used to be a CO double bond, right? That's the CO double bond. This carbon that carries the OH. What should be your Grignard? What alkyl group should we start to make the Grignard? What alkyl group should we start to make the Grignard? We have a choice to start either with this side or this one, but only one of them. One of them is coming from Grignard. One group attached to the carbon carrying OH is coming from Grignard. The other, everything else, attached to the carbonyl group. So this is H and this one is C. This is my carbonyl group. So I know that this part of the molecule is coming from carbonyl group. So this part is coming from RX, from alkyl halide. So you cut the molecule to two pieces. This side is one side is coming from alkyl halide, which first you have to change to Grignard, and the second part is coming from carbonyl group. So this side of the molecule is coming from carbonyl group, and this side is coming from alkyl halide. Now you can make your alcohol. We know that we have to start with propyl. So should I use propyl bromide or should I use propyl chloride? It doesn't matter. Both of them would work, but bromine is a faster, better leaving group, so it can leave faster. So you're going to make your Grignard. Why I'm making Grignard every time? Because you cannot purchase Grignard reagent. Grignard reagent is very reactive, very unstable. It has to be prepared in the reagent, in the reaction mixture, and be consumed right away. So you have to make your Grignard, unless the formula is giving you the Grignard, assuming that you just made it there on the spot in the reaction mixture. So you have your propyl magnesium bromide or propyl Grignard. You make your Grignard. Then you're going to make this react. This is a strong nucleophile to react with the carbonyl group. What should be your carbonyl group? Because the structure is given to us is this. The carbonyl group should be acetaldehyde or ethanol, which is 2-carbon aldehyde. So your Grignard is going to react with the acetylide ion, I'm sorry, with the acetaldehyde. So negative charge from here. So we have pair of unshared electron, negative charge and a positive charge here. This negative charge is going to form bond with the carbonyl carbon. There is no leaving group, so the oxygen is going to take the pair of electrons from pi bond. So the pi bond breaks over the oxygen. The carbon-carbon bond that is forming, you have to pay attention to these, like details when you are writing yourself, is the bond between the carbon from Grignard or the nucleophilic carbon and carbonyl carbon. Please do not make a bond between this carbon and the carbon that is attached to the carbonyl. So it has to be the carbonyl bond. So you're going to write your product or alkoxide that is forming. You have a new bond that is forming between the propyl group with the carbon from carbonyl. What is happening to the pi bond? The pi bond is breaking over the oxygen, so oxygen would get the negative charge here. Anything attached to carbonyl group is going to stay attached to carbonyl group. So you're going to have a hydrogen that is attached to carbonyl group and the methyl that is attached to carbonyl group. Now, should I write the methyl in this location or the hydrogen? It doesn't matter. So you could write it straight or you could write it down because this carbon chain can bend unless they specify that this is like a R or S or if it makes a difference. Okay, so at this point, either way, you could write the hydrogen straight line carbon down, but since the structure of the product that I gave you, it looked like this, I just want to make sure that it looks same. Then you cannot leave it like this. It's not going to give you alcohol. You have to hydrolyze it. So in your reagent mixture, whenever you are working with the Grignard, you have to follow up with hydrolysis. Now, you start with aldehyde. So this is the aldehyde. And you get secondary alcohol. With formaldehyde, you got primary alcohol. With aldehyde, you get secondary alcohol. Now, in order to get tertiary, we had this just for the acetylide ion also. In order to get tertiary, now you have to add ketone. So for a tertiary alcohol, let's say you want to make this tertiary alcohol. What should be is a tertiary? What should be the alkyl halide? The alkyl halide is coming from any of these groups. So it could be ethyl, methyl, or ethyl. So it doesn't matter which one. You pick one for alkyl halide, and you do have choice. There is no preference here because anything can make Grignard. Methyl can make Grignard, ethyl can make Grignard. So if you take this one coming from Grignard, then the other two would come from ketone. This carbon here, it used to be the CO double bond. And the CO double bond is attached to two alkyl groups. So it's going to be one ethyl group and one methyl group. So Grignard plus ketone, it gives you tertiary alcohol. Okay. Grignard plus ketone. Now, to make the Grignard reagent, so when you have your Grignard reagent, so you have to make your Grignard reagent first. That would be ethyl bromide plus magnesium. It gives you this Grignard reagent. That is going to react with the carbonyl group that you have there, which is the ketone. So electron movement is from nucleophile to the carbonyl group. The pi bond is going to break over the oxygen. The new bond that is forming between this carbon A and carbon B. Okay, so if you mark these, it's going to make your life easier learning it and being able to rearrange it. And if not, when it gets complex, when you get like a 5, 6, 7, 8 carbon site, then it's going to be hard to manage. But if you understand that the new bond that is forming between the carbon from Grignard and the carbonyl carbon, everything else stays the way they are, then there is really nothing too complicated about this. So you end up with CC from the ethyl group from the Grignard. You have a new bond between that Grignard and the carbonyl. This is the new bond that is forming. And that's your A. This is the B. The pi bond will break over the oxygen from carbon B, negative charge. The other groups that are attached, and it is attached to the carbonyl group, is going to stay. So if you have a ethyl group here and a methyl group, what's next step? What is the next step? Next step would be hydrogenate. So we have to hydrolyze it. And when you hydrolyze, you will get your tertiary alcohol. Okay, so probably the next few slides is just talks about everything that we have already know, and we talked about it. If you want to get the primary alcohol, you are going to use formaldehyde. Okay. For primary alcohol, it would be reaction of Grignard with formaldehyde, and the product, if you compare the reactant to the product. So Grignard is going to be your reagent, let's say. This is your reactant, so Grignard would be the reactant. If you compare the reactant to the product, if I take this as a reactant, as a product, your product is the alcohol with addition of one carbon. So if you have the RMgX, you have here you have the RCOH. So if you go back to the video, to the example that I had there, if you start with 3 carbon Grignard, you end up with 4 carbon alcohol. You start with 2 carbon Grignard, you end up with 3 carbon alcohol. Here you're starting with 4 carbon Grignard and you end up with 5 carbon alcohol. So addition of 1 carbon. If you have Grignard and formaldehyde, the product is going to be primary alcohol. So these are things that is going to, if you memorize it, is going to help you to build the molecule and be able to come up with the structure of the 2 reactants. If you were doing the retrosynthesis or if you were writing forward reaction, know that you will get R group from Grignard with addition of 1 carbon to make the primary alcohol whenever you are using formaldehyde, because there is one other compound that can give you primary, but it's not general. That's like very specific. It's just one other compound that you could use. To make secondary alcohols, you're going to use aldehyde. So how many carbon you would get on the product side? It depends on the size of the aldehyde, and it depends on the size of the alkyl halide you start with. So the number of carbons that is coming from alkyl halide is going to be attached to the carbon with the OH, and then whatever number of carbon you have from the aldehyde is going to also attach to the same carbon. Is not going to be in the same carbon chain, but both of them will attach to the carbon, alcohol carbon, and you end up with secondary alcohol. Like in this case, you have a methyl group that is attached to carbonyl, and you have an ethyl group that is attached, is coming from Grignard. On the product side, the carbon that carries the OH is going to carry 1 methyl group. This was originally coming from aldehyde, and an ethyl group that is coming from Grignard reagent. Tertiary, you have 1 group coming from Grignard, 2 groups are coming from ketone that you start. So if you want a tertiary alcohol, you have to start with ketone, or you have to make your Grignard react with ketone, but the steps are always the same. This problem we solved already, this problem, but you do have a choice. You can make ethyl group Grignard, you could make methyl group Grignard, or you could make the cyclohexyl group as a Grignard. So whatever you take as Grignard, the other one is going to be your ketone, because this is the tertiary. Because it's tertiary, it has to be Grignard plus ketone. Now, your ketone, it could be Two R groups are coming from ketone. So it could be A and B, it could be A and C, or it could be A and C. Any of these can be the can come from the any combination. It can come from ketone. So if it's the A and B, you get this ketone. So you have your ketone. The other group is going to be responsible for the Grignard. So if you take this piece as the ketone, then this one is going to be your Grignard, basically RMGX. Okay. So either one of them, any combination can work, and you have these two examples. Any questions? No questions? Okay. So we can make the primary alcohol Grignard plus aldehyde, secondary alcohol would be Grignard plus aldehyde, and tertiary alcohol from Grignard plus ketone. So sometimes the question is a little bit more specific, and it says that your reactant cannot have more than 5 carbon. You have here 7 carbon, and here you have 8 carbon. So that is a proper method to make this. But if you are restricted to only 5 carbon or no more than 5 carbon, these are not going to work because you have more than 5 carbon. So you have to make your ketone coming from ethyl methyl ketone, and then your alkyl halide coming from this group to make it fit with the requirement from this question that you want to start with the less than, with no more than 5 carbon. So that's the limitation there, or restriction that question is asking you to apply. So you use the ketone that is 5 carbon, and then the Grignard with 5 carbon. Grignard reagent, it can attack any carbonyl group. As I said, this is a carbonyl group, but how is that different from aldehyde or formaldehyde and ketone? The compound is called acid chloride. The difference between acid chloride and formaldehyde or ketone is that here you have a leaving group. So if you have leaving group, what would be the difference? Can you tell me, if you have leaving group, what would be the difference? What's the difference when you have a leaving group? When you have leaving group, when the R group comes in, leaving group is going to leave. So the pi bond is going to regenerate. Okay, the pi bond regenerates. So the first step 1, let's say you have a ethyl. You have ethyl Grignard plus what is this? Propanoyl chloride What would be the first product? The first product, when the nucleophile attacks this carbonyl group, leaving group is going to leave. So you are going to end up with 2 carbon here and carbon. Your product is going to be a ketone. So you get basically 4 carbon from this and 2 carbon from, you get ketone. Or 2 carbon either side, 3 carbon on one side. And what do we have here? We have ketone and we have Grignard. So if Grignard attacks the ketone, it would change to tertiary alcohol. So 2 moles of Grignard plus acid chloride will give you tertiary alcohol. Same thing for Grignard plus ester, which is the acid derivative. This is the leaving group. First mole of Grignard is going to attack this carbonyl group. Leaving group leaves, you end up with ketone. But we know that ketone is reactive in response to the Grignard, so it's not going to stop there. And when it doesn't stop, then the second mole of Grignard is going to react with ketone, and it gives you tertiary alcohol. Now, when it changes to alcohol, then there is no pi bond here, there is no good leaving group here, then the reaction is going to stop. In order to change this to better leaving, you have to protonate it. So you have to bring water or acid, but when you bring water or acid, it's going to destroy the Grignard, so the reaction is going to stop in formation of alcohol. So when the alcohol forms and you hydrolyze it, at the same time that you protonate your alkoxide, you're also destroying your Grignard reagent. Okay, with the acid halide, first, or the intermediate compound that you're going to make is a ketone. The second mole is going to react with the ketone, and it gives you tertiary as the final product. Questions? So I'm repeating one more time. So far, what we have, Grignard plus aldehyde, what do you get? Grignard plus formaldehyde, what do you get? Primary. Grignard plus aldehyde. Secondary. Grignard plus ketone. Grignard plus ketone, tertiary. Grignard plus acid chloride. Grignard plus acid chloride. It's two-step reaction. First, you get ketone, and the second step you would get tertiary alcohol. The acid chloride was the one that had the leaving group. That's your acid chloride. It's known as derivative of carboxylic acid. So that's 4. 5, Grignard plus ester, what do you get? What do you get from Grignard plus ester? Also tertiary. So Grignard plus formaldehyde primary, plus aldehyde you get secondary, plus ketone you would get tertiary, plus acid chloride you would get tertiary, and plus ester you would get tertiary. You have to write them as a note to yourself because it's going to help you to make alcohols, or it's going to help you to write the product for the reaction. Next reaction, so far we had 5. Now, reaction 6, Grignard plus also ketone. The first step for ester produces ketone because your leaving group is this and is going to leave. Okay? That's the leaving group. It will make it ketone, and then attacks ketone, gives you tertiary. Grignard plus ethylene oxide. Ethylene oxide or epoxide in general, if it's ethylene oxide specifically, you will get primary alcohol. But what's the difference from ethylene oxide compared to formaldehyde? For ethylene oxide, you get addition of 2 carbon. For formaldehyde, you get addition of 1 carbon only. If you look at the mechanism for this reaction, the Grignard with the negative charge on the carbon is going to attack one of these 2 carbons. And if it's symmetrical, it doesn't matter which one. The weakest bond will break, and that weakest bond is the bond that forms the triangle. Because of the angle of strain, this is very weak bond. It can break easily. So as soon as the nucleophile attack takes place, this bond is going to break over the oxygen, and you end up with alkoxide. You protonate the alkoxide, you get alcohol. Comparing reactant, which is your Grignard, to the final product, you have addition of 2 carbon. And the product is a primary. So far, you have 2 methods to make primary alcohol using Grignard. One is Grignard plus formaldehyde, the other one is Grignard plus ethylene oxide. You have 3 methods to make tertiary. If you make Grignard attack the ketone, acid halide or acid chloride, and ester. In either case, you would get a tertiary. To make secondary, 1 method only, Grignard plus aldehyde. And how many carbons should be their side? It depends on what you want to make. So the other reagent that can break this ethylene oxide is alkyl lithium. So if you had alkyl lithium, like ethyl lithium has a positive and negative charge, this can also do the same reaction. So it can break the ring and you end up with a secondary alcohol. Now, if it's not ethylene oxide specifically, not sure if it's covered here. No, but you might see it on the test. Let's say if there is a methyl group here attached. Okay, so if you have a methyl group here attached, are you going to get the primary or secondary alcohol? Another question, would the nucleophile attack this carbon A or carbon B? If you had a methyl group attached to carbon A. To carbon B. Why carbon B? Because carbon B doesn't have the supporting group. Carbon A, it's a basically a secondary here, is going to be supported by the plus charge that you have. The plus charge, where would be the charge more stable? Because this is nucleophile and looking for nucleus, right? Is looking for the plus charge. Would the plus charge be more stable on A or more stable on B? The plus charge would be more stable on which carbon? Carbon A or B. I wrote the A on the right side, B on the left side. The plus charge is going to be more stable on carbon A, so the attack would take place on carbon. So it depends on the oxide or epoxide that you are dealing with, and also which carbon would take the nucleophile in. You might get a tertiary or secondary using epoxide. What are the limitations for Grignard? No water or acidic protons. It can be in the reaction mixture. Okay, acidic protons is OH, NH, SH, or terminal alkyne. So these are the limitations. No other electrophilic multiple bonds like a CN double bond, CN triple bond. Sulfoxide or oxide. So none of these should be in the reaction mixture. What's the problem with this? If you have a OH in the reaction mixture, then it can destroy the Grignard reagent. So if you have a H2O, you are going to change your Grignard to alkane, and this is like very stable. So MgBrOH or MgClOH, this is going to be very stable. So your Grignard, which was a nucleophile, is changing to alkane, and as soon as it changes to alkane, that means your Grignard has been destroyed. It's not active anymore. It has been destroyed. So any ionizable hydrogen or acidic proton, it can protonate the Grignard, and if it does protonate the Grignard, basically takes away this negative charge from the carbon. It changes to very unreactive alkane. And if this happens, your Grignard has been destroyed. What can destroy your Grignard? Any acidic proton and water. It can destroy your Grignard. And the last step of the preparation of alcohols using Grignard, we must hydrolyze. And when we do hydrolyze, it does two things. One, protonates the alkoxide. Second, it deactivates the Grignard. How does it deactivate? Basically changes the Grignard to alkane. Other methods for preparation of alcohol. Reduction of aldehyde would give you alcohol, primary alcohol. Reduction of ketone would give you secondary alcohol. Now, when you say reduction, what does it mean? Reduction meaning adding hydrogens. Okay? So reduction, adding two H's. What takes the H? The two elements that are engaged with the double bond, each one is going to take one H. So if each one takes one H, that is going to follow the definition for reduction. So you are going to end up with OH here and H. This is the reduction reaction. Reduction meaning adding two hydrogens or removing one oxygen. But in this case, we already have the oxygen. We have the CO double bond. We can add two hydrogen and reduce it. If we reduce aldehyde, we end up with primary alcohol. What is a reducing agent? A reducing agent is something that can attack the carbonyl group, and it contains hydrogen. Sodium borohydride it has a hydride. Hydride is different from H and is different from H+. Hydride is a nucleophile. H plus is electrophile. So nucleophile, basically from the sodium borohydride, which is the hydride ion, it can attack this carbonyl group. The pi bond is going to break over the oxygen and then be protonated later. Okay. The other reducing agent we have is lithium aluminum hydride. What's the similarity? Both of them, they have hydride ion, and hydride is acting as nucleophile. So it can attack the carbonyl group, alkoxide would form, and then you would protonate. That's the similarity. What is the difference? Sodium borohydride and lithium aluminum hydride. The difference is lithium aluminum hydride is a stronger reducing agent, and this one is weaker reducing agent. Sodium borohydride can reduce aldehyde and ketone. It cannot reduce carboxylic acid. It cannot reduce ester, acid chloride, and other more oxidized compounds. But it can reduce aldehyde. It can reduce the ketone. Lithium aluminum hydride, it can reduce everything. So it's a stronger reducing agent. The other reducing agent you have is ranine nickel with hydrogen. So every time you have nickel by itself doesn't have hydrogen. So basically it's a H2/nickel. So ranine nickel with the hydrogen. So you have your reducing agent, H2 with nickel. H2 with nickel, this can reduce CC double bond, would change to CC single bond. Sodium borohydride plus CC double bond is going to be no reaction. So there are some similarity and some differences. So first of all, you need to know what are the reducing agents. Second, you need to know when to use what. Reduction, meaning addition of hydrogens. So instead of aldehyde, if you had ketone, how would that make a difference? So if you have a ketone and you add sodium borohydride, this reagent is a reducing agent. That means it's going to add 2 hydrogen, whereas the hydrogen added to the oxygen here and to this carbon, because the pi bond is going to break. And what would be your product? That's why you get secondary, because the secondary alcohol, because the hydrogens are added to the carbonyl carbon and the oxygen from the carbonyl group. So the carbon skeleton doesn't change in this case. The carbon skeleton stays the same. If you have aldehyde, you're adding hydrogen to the terminal carbon, and if you have ketone, you would add the hydrogens to the carbonyl group that is internal. So you could get a secondary. So it's memorizing. Aldehyde would give alcohol, ketone would give you secondary. Aldehyde would give you primary, and ketone would give you secondary. When it comes to the sodium borohydride or sodium borohydride with the ranine nickel, which one are you going to use? It depends on what you want to reduce. If it's aldehyde or ketone, use sodium borohydride. If you have a CC double bond in the reaction mixture and you use sodium borohydride, with sodium borohydride, you are going to maintain the CC double bond because this is not going to affect it. So you end up with alkene and OH here. But if you use H2 with the nickel, with the ranine nickel, you are going to get single bond. You get the primary alcohol here. But at the same time, it gets saturated. So do you want to keep the CC double bond? Then use sodium borohydride. Okay, it's going to keep the CC double bond. If you use nickel, there is no CC double bond left. It saturates both or reduces both. The way sodium borohydride works, hydride from sodium borohydride acts as a nucleophile, attacks the carbonyl group, alkoxide is formed, proton, and you get your alcohol. LAH, same way. H hydride is going to attack the carbonyl. It would form the alkoxide, protonate, and you get alcohol. So it works the same way. But LAH is more aggressive and it is more expensive. So if you have the choice of using sodium borohydride, use the sodium borohydride, because LAH is going to be more dangerous to work with because it's a stronger reducing agent. So if you have a choice, you would use one that is less risky, less dangerous. Because it can also convert the carboxylic acid into primary alcohol. Questions? Any questions? It's a lot to memorize. Okay, there's a lot to memorize, and I understand that. But at least, when you do OR assignments for chapter 10, you do end of the chapter problem. Please read the chapter. Do not only depend on the PowerPoint, because PowerPoint is not book. It has the summary of everything, but if there's anything that is when you read the book, it gives you more examples also. So with the practice, you're going to get the OR assignment, especially, it has a lot of questions that makes you go back to read the book. And that's why if you just search for the answers for the OR, it's not good enough. But if you go back to book, read the section, is going to prepare you definitely for the test, for the quiz and for the test. Okay, so reducing agents, we could have lithium aluminum hydride or sodium borohydride. Lithium aluminum hydride can reduce aldehyde and ketones. Lithium aluminum hydride, because it's a strong, it can reduce aldehydes, ketones, esters, and other acids, carboxylic acids in general. So if you're concerned about preparation of the alcohol, aldehyde would give you primary, ketone would give you secondary, ester is going to give you primary, and carboxylic acid would give you primary. Only ketone in this case would give you tertiary. Now, ketone would give you secondary. Can you make tertiary alcohol by reduction? The answer is no. You cannot make tertiary alcohol by reduction. It's either for primary or secondary. Then you can use reducing agent. Okay, the other advantage of the using of sodium borohydride. Sodium borohydride would give you primary alcohol with aldehyde, secondary alcohol with ketone. But let's say if you have two functional groups here, you add sodium borohydride. Sodium borohydride would reduce to secondary alcohol because it's ketone, but it's not going to touch the ester functional group. So your ester is going to stay as ester. What happens if you add lithium aluminum hydride is going to reduce the ketone to secondary alcohol, and it will reduce the carboxyl group or ester functional group to primary alcohol. So it will reduce both of them. So sodium borohydride is more selective for primary and for making primary from aldehyde, secondary from ketone, but lithium aluminum hydride, because it's a strong reducing agent, is not selective. Granite nickel, which is the H2 with nickel, is going to reduce the carbonyl and is going to reduce the carbon-carbon double bond, as the example that I had earlier. So you are going to see no carbon-carbon double bond. If you want to maintain the carbon-carbon double bond, you have to use the sodium borohydride, because it's going to reduce the carbonyl, but it's not going to touch the CC double bond. So you have to learn about what are the reducing agents and when to use which one in order to make alcohols. What are thiols? Thiols, they are just like alcohols. So instead of O, you have sulfur. Instead of the oxygen, you have sulfur. So instead of H, you have SH. That's for thiols. Have to make thiols, you have to use the sodium hydrosulfide. So sodium hydrosulfide, NaHS. Sodium hydrosulfide. Make it react with alkyl halide. This is going to bring the hydrogen sulfide as a nucleophile, and leaving group is X. You get the SN2 type reaction. And you're going to replace the halide with SH. That's like preparation of this for SN2 type reaction. So oxidation reduction takes place for alcohols. It can take place similarly with the thiol. So if you know about the alcohols, it's very similar reaction with the thiols also. So you can oxidize your thiols, you can reduce your thiol. When you're reducing thiol, basically you're adding hydrogen. So if you have a sulfide bond or disulfide bond or disulfide bridge that is between two amino acids, you are going to, in order to break it, you have to reduce this, and to reduce it, you're just adding hydrogen to SH, and to make it SH and SH, so you're going to break that bond. And to oxidize, when you oxidize this, it's removing two hydrogen. So oxidize is either add OH, add oxygen, or remove two hydrogens. Reduce means add 2H or remove oxygen. So if you're removing two hydrogen here, that means you're oxidizing and you make that disulfide bridge or disulfide bridge. What type of reactions you could make the alcohols go through? You're going to learn about all of it in this chapter, but this is the list of the reactions. We have dehydration of dehydration to alkene covered in chapter 7. To make the alkene, you start with alcohol, and then you would use concentrated H2SO4 to change to alkene. What concentrated H2SO4 is going to do is going to protonate the OH first, changes to H2O. H2O would leave, you have carbocation, you remove hydrogen from adjacent carbon to change it to alkene. Alcohols, if you have a primary alcohol, you can oxidize to aldehyde, and secondary alcohol oxidize to ketone. If you have reduction, is going to prepare alcohol, but oxidation is going to consume alcohol to form either aldehyde or ketone. Substitution to form alkyl halide. So if you have OH, you would add PBr3. This is going to give you CBr. Reduction to alkane. Reduction to alkane. So if you have CCOH, see, you cannot reduce this by adding hydrogen because all bonds are saturated. But in order to reduce this, you have to remove the oxygen. How could you remove the oxygen? It has to be a two-step reaction. First, you have to change this to alkene. Then you have to protonate it. So minus H2O first, and then you're going to protonate it, and you will get alkane. Reduction of alcohol, it will give you alkane, two-step reaction. First, you have to do dehydration. Second, you have to do hydrogenation. So you protonate or hydrogenate. Esterification, formation of the esters. Alcohol plus acid gives you ester. Tosylation, to change it to better leaving group. Williamson synthesis of ether. That's another reactions of the alcohol, and you will learn in most of the reactions, most of these reactions in organic too. So you can start with the alcohol to go to alkene by dehydration. You can oxidize to get aldehyde or ketone. You can do substitutions to get alkyl halide. The reagents are not introduced here. It's just a summary of the reaction. You can reduce to alkane. You can do esterification, tosylation, or formation of ether. Questions? The final exam is a cumulative exam, so it shows the understanding of all the chapters. So I'm sorry, no. Yes, we do have exam 3, but no exam 4. We have exam 3 and then we have final. That's okay. You should ask, because if you don't ask, you don't get it, but sometimes it's not done. You have your exam 3 and then you have your final exam. Do you have any questions about the chapter? If you don't have any questions about the chapter, I can stop the recording, and then we talk about about the quiz and exam. No question about the chapter? No? Okay.